Hello, Fadla. I don't know if you can hear me. I hope I got your name pronounced correctly. Yeah. So, thanks for joining in early.
Hello. Hi, everyone.
Hi. Hello. We have our speaker on. Yeah.
Nice to meet you.
Yeah. Nice to finally meet you. Thanks
How are
for
you doing?
joining in.
Yeah, of
I'm
course.
doing great.
Perfect.
Yeah. Don't know if you could see me.
Yeah. And thanks for organizing this bootcamp and this session.
Oh, you're welcome. We officially started last week. We've only had one section that was on Saturday, and it was really nice, basically. And we also took it on Friday. Yeah. So we have you today, and we're going to have Bruno come in tomorrow. He's going to take a session of co-pilot. Yeah. So it's really nice to have you guys come in and support us. Nice. Thank you.
Nice for me to be here.
Yeah, I would like you to meet other leads for the WGMIT community board. They're having like joint events. So hopefully they join in shortly. So we are actually supposed to start in like 6 minutes.
Yeah. I'm going to, do you want me to share my screen already, or do you need to share
And
some introductory text first?
no, we do not have any completed. So we just like say for the call and stuff like that.
Okay, so let me load my presentation and maybe I can quickly test my screen sharing. Will you be there for the whole duration of the session, Olivia, if there's any kind of moderation needed in the chat?
Okay. For the chat, yeah. People could ask the questions. To drop them into chat. I don't know if you could access the chat as well.
I think so. It looks like I was checking. It looks like I can access the chat.
Okay. Yeah. So let's just chill a little bit for other folks to come in. And I think the session is ready for 4 minutes. So.
When I go to the browser, you can see the browser, right?
Yes, I can.
Perfect. Okay, cool.
Okay, seems like we have coach joining in already. Yep. I can see Natasiba, I can see Badzai. I hope I pronounced your names properly, please.
Yes, that's correct.
Yeah, thank you. Yeah, I can see Dia as well. Yeah. So Carlotta, Dia is one of the leads for the women and gender minority tech community. Yeah. Yeah, I don't know, Dia, I don't know if you're free to probably say hi, aside from saying hi in the chat.
Yeah. Yeah, I can. I confirm I can see the chat.
Sukuma na chala mamit. Sukuma na chala mamit.
Okay, so it seems like we have folks joining in already. Yep. So we start officially in 2 minutes. Okay, so good evening from here, everyone. I am Olivia once again. Yeah, you already met me during the onboarding and the last section we had. So we'll be kicking off shortly. I mean, it's already 5 p.m. And I would like to say welcome to this very, very, very unique section for our very own Carlotta. She's a cloud developer advocate at Microsoft, and she'll be handling the Azure AI Bootcamp. Sorry, introduction to Azure AI Studio, rather. Yeah, very sorry. That up. Yeah, she'll be handling the introduction to Azure AI Studio, and I hope you guys get a lot of insights on how to use Azure AI Studio. Yeah. Over to you, Carlotta.
Thank you so much, Olivia, for the introduction, and welcome everyone to this session. I'm Carlotta Castelluccio, and as Olivia just mentioned, this talk is an introduction to Azure AI Studio. So hopefully we're going to put into some practice some of the concepts you might have heard already while attending other sessions, maybe about generative AI. But focusing on the Azure AI platform, and I will present some hands-on demos on how to leverage it to build custom generative AI solution. Feel free to ask questions in the chat, or also raise your hands if you have any questions in the throughout the session. But we can also have a Q&A session at the end. Before deep diving into the topic of today's session, just wanted to briefly introduce myself. I'm a cloud advocate in the AI advocacy team at Microsoft. And it's been a few years now that I work in the AI field in Microsoft. I started as a field engineer supporting customers in building conversational solution, which means chatbots, voice bots, at a time when, building a chatbot wasn't really as easy and as cool, I would say, as today. I'm a public speaker and technical writer, and my mission as an advocate is to help developers make the most out of Microsoft AI technologies and building innovative solutions responsibly. I'd love to start this session by giving you some numbers, some statistics that depict a clear framework of AI usage today, especially in the work environment. In fact, Microsoft and LinkedIn early this year have published the 2024 Work Trend Index annual report, looking at how AI will reshape work and the market broadly, and interviewing more than 30,000 people worldwide and analyzing data from hiring trends on LinkedIn and Microsoft 365 productivity signals. Among all the insight you can find on the report, I found quite relevant the 3 points highlighted in this slide. First of all, 75% of global knowledge workers use AI at work, which means they use generative AI, which means that the usage of generative AI has nearly doubled in the last 6 months. And 79% of leaders worldwide believe they need to adopt AI to stay competitive. And the last one, particularly impressive to me, 66% of leaders declare they would not hire someone without AI skills, and an even higher percentage would hire a less experienced candidate with AI skills rather than a more experienced one without them. So that's the AI landscape, the current AI landscape. And in this context, in this landscape, I would like to propose to you today a real-world scenario of a fictional company called Contoso Outdoor Company. And we are going to imagine that we are a developer for this Contoso Outdoor Company, which is a fictional leading e-commerce company that sells outdoor gear and equipment. Contoso is working on a new website design, and we have been tasked with generating text copies and code snippets for the website. And we want to, of course, use the power of generative AI to do so. Well, to address this scenario and build your generative AI solution able to help you with the website design, you should look no further than Azure AI Platform, which provides you with the best in-class AI foundation models, and it has everything you need to build your AI application safely and responsibly. As a response to the AI paradigm shift and the huge wave of innovation of recent years, the Azure AI Platform has been recentered around Azure AI Studio, a hub unifying all data and AI services in the Microsoft Cloud. It includes all the Azure AI services you might be familiar with already, the so-called cognitive services designed for specific domains like speech or vision. It includes Azure machine learning features, and it provides you with actionable tools to safeguard your system against the latest threats and operationalize responsible AI principles. But Azure Platform is more than that. So if we zoom out a bit, we can see where Azure Studio sits in, and it sits in a larger AI toolchain, which makes integration seamless for familiar open source tools and frameworks such as Semantic Kernel or LangChain. The Azure Platform meets every developer where they are, whether they prefer a low-code approach with the UI, UX experience, a command line interface with the Azure Developer CLI, or a code-first experience. But for the sake of this session, we're going to focus on our goal to build our AI application prototype in Azure AI Studio. And Azure AI Studio is generally available to everyone and accessible at ai.azure.com. So if you haven't already, I really encourage you to start exploring the hub. And Azure AI Studio enables you to do 4 main things. So innovate, being able to explore the latest and greatest models on the market. Differentiate, so enriching the models with the most relevant and timely knowledge to engage your application users. Safeguard your system by applying moderation filters and attacks mitigation to combat the latest threats. And operationalize by equipping developers with open tools to collaborate and iterate continuously throughout the end-to-end development lifecycle. But without further ado, I would like to jump into Azure AI Studio directly to start with our very first demo. So the first thing, let me go directly to the landing page to get started our tour. And the first concept to grasp when getting started with Azure Studio are the AI Hub and the AI project. you can see in here that I have a recent project already created. Now, an AI Hub provides a collaborative workspace for AI solution development and management. And you need at least one Azure AI Hub to use the solution development features and capabilities of AI Studio. Then an Azure AI Hub can host one or more projects, and each project encapsulates the tools and assets used to create a specific AI solution. Basically, a hub enables you to define shared assets that can be used across multiple projects. So if we go into all resources, we can see, all the hub available in my subscription. And then if we click on the on one of the hubs I have in here, I get the hub overview, where there are a few, we can find some useful information about the hub. For example, the hub projects that we have defined beforehand. In this case, I only have one project in my hub, but I can have multiple projects sharing the same assets. I can find the hub properties, which is a collection of various properties, such as the hub's name, its location, the resource group. And here we can also find, for example, the API endpoints and keys, or the subscription quota. Then we have the connected resources section, because Azure AI Studio allows for multiple resources to be connected to a hub, expanding its features and functionality. And resources such as Azure AI Search, we can see here Azure AI Service, further increase the capabilities of our hub. And then we have the permission sections that allows you to grant access to collaborators or applications that may need to use the services within the hub. So next, if we click in the project, we can create, we can notice, that the navigation bar has been updated with some new tabs, which represent functionalities tied to our project. First of all, we have the Get Started section, where we can discover the capabilities of the pre-built models available in Azure AI Studio. In particular, the model catalog in here provides more than 1,700 open source and proprietary models inside Azure AI Studio. And we can look for the models we need by using all the filters in here. For example, we can filter by model provider. We have different collections in here: Azure OpenAI, Microsoft, Meta, Mistral, and so on and so forth. We can filter by inference task, for example, text generation, text classification, etc., or by license. Or we can also just type the name of the model we are looking for. For example, I can look for Phi-3 Mini, which is one of the latest models for small language model developed by Microsoft Research. And once I find the model I want to use, I can click on it and get what is called the model card, which is basically a presentation of the model with a description, some information about the training data set, the intended use cases, but also, for example, you see some benchmarks, and you also have, for some models, like Phi-3, you also get a playground in here, so you can basically test the model before deploying it. And then you also have, the information about the deployment options. So you can get all of this information by looking at the model cards for each model in the catalog. And then another helpful feature to, look into the model, which is more useful for your use case, is the model benchmark, because here you can compare benchmarks across models and data set available. So which means that you don't need to have your own data set and upload your own data set to compare different models, but you can choose between at least a set of public available data set. And then you have benchmarks of the models against different metrics. And also you can visualize through charts. So you have model accuracy, you have coherence, you have groundedness, all the, common metrics you use to basically compare models. So this is about the model exploration, while the next section, the project playground, is more on the building phase. So the project playground sections is basically where you can interact directly with the GPT models you deploy in your Azure subscription through Azure OpenAI service. And each option of playground in here represents a different approach to interacting and using an AI model. And each playground mode is designed for a specific use case. For example, the image playground in here is designed for image generation task. We have the completion playground, which is designed for text generation task. And in addition to that, the chat playground allows you to create a quick prototype of a multimodal copilot that you can customize, evaluate, and deploy as a web app. And we're going to use these in our next demo. But for now, let me just jump back to the slide and go ahead with our Azure AI Studio exploration. Because hopefully this introduction, alongside with the AI Studio tour, gave you a fast glimpse about the AI platform in Azure. For the rest of this talk, I'd like to focus on this specific area of the 4 areas we presented previously, which is the differentiation. Because if Microsoft makes the platform, the Azure AI platform, you as developer really makes the difference. I'm seeing a question from Grace. Will we be charged if we train models on Azure AI Studio, and how much will be charged? Yes, of course, training models on Azure AI Studio. So the models I have showcased to you in the model catalog are pre-built models. So unless you have specific needs to fine-tuning and customize these models, you don't need to train the models. Of course, there's a chance for you to train models from scratch, but this is not in Azure AI Studio. This happens more in Azure Machine Learning Platform. But anyway, also both training and usage, so inference of the models itself, of course, come with some charges. And charges depend from the model you choose. There are more powerful models, there are more expensive models, less expensive models. Small language model, for example, usually have a good balance, like 5.3 Mini, usually have a good balance between cost and performances. But there's no, common cost for every model. And also it depends from the input you add into the model, because the longer is the input to the model, the higher would be the cost of each call. And then I'm seeing another question. Can I develop my model on AI Studio and use the existing data set? Again, Azure AI Studio offer a set. So the model catalog I've showcased to you is a model catalog in which you can find pre-built models, and these are large language models. So models that are trained on high volume of data, which is not the kind of model you can easily train on your local machine, because it involves huge amount of data to train the model. So AI Studio is more for using pre-built models trained on billions of parameters and huge amounts of data. When I say huge, I think about the whole internet. So we are talking about models like ChatGPT, if you are more familiar with, these kind of models. And And while if you want to build your models from scratch, the platform which makes you do that in Azure it's called Azure Machine Learning. Great. So now, as I said, if Microsoft makes the platform, you as a developer really makes the difference. And what does it mean? It means that starting with powerful models, so the pre-built models we have seen in the catalog, is key. But your input to the model makes you tailor your model selection for your specific needs and users. And yes, we are talking about prompt engineering. And maybe you want to share in the chat how many of you are, familiar with prompt engineering techniques already, or have used large language models already. I would be curious to know that. Now, prompt engineering is the process of designing the model input to deliver consistent and quality responses. And there's a few reasons why you should care about it. First of all, generative AI models are stochastic. So for the same input, you don't always get the same output. Generative AI models can fabricate responses. So the model will always give you an answer. And if it doesn't have the context to give you the right answer, because it cannot access the freshest data, for example, or private data, it will invent an answer for you, which is something you want to avoid, of course. And models do not have memory of previous interactions. So if the model knows the history of the conversation when you interact with the model through the playground, it's just because the app which is built on top of it is passing an input to the model, the conversation history. So prompt engineering is a non-trivial task. The input to the model is generally composed by a system message or model prompt used to provide the model additional context to generate an answer. And the user prompt, which is the actual question or request. Now, the system message usually remains the same for the whole session of interactions with the model, while the user prompt varies at every turn. So if we zoom into the system prompt, this might contain several information, the description of the task to accomplish and the behavior expected by the model, the tone and style of answers, some safety guardrails. For example, you can instruct the model to do not cover specific topics or decline any request to generate content that can harm a group of people. You can include jailbreaks, mitigations. For example, you can instruct the model to do not reveal its rules and make the user change them. You can also add some data sources that the model should use to ground responses, and we'll see these in a bit. And we can add the conversation history. So as I mentioned before, we can pretend that the model knows the conversation history by passing the previous interactions with the model in the prompt. On the other hand, if we zoom into the user prompt, this might contain one or several instructions for a model, optionally accompanied by a primary content. For example, an instruction can be summarize the text below, and then the text that follows this instruction is what we call primary content. The user query can include one or several questions. It can include examples of input and output for the task we want the model to complete. It can include also cues, so a jumpstart prefix that can help the model to generate the desired output. Now, in addition to that, there are some parameters that you can set to tune the model's output. You can set the temperature, which controls the degree of randomness of the output generated by the model. A higher temperature will result in more diverse and unexpected responses, while a lower temperature will result in more conservative and predictable responses. And top P parameter, which is another way to control the degree of randomness in the choice of the next predicted tokens for the model by setting a percentage of probability where the model should look into. Now, the first best practice in prompt engineering is give your model clear instructions. So you can imagine you are speaking to an untrained intern, so you need to avoid assumptions, providing contextual specificity for the task the model should perform, break down the request into simpler instructions or a smaller task, and you can do that directly in your prompt or guide the model to do so by using techniques like chain of thought that we are going to see in a bit. And provide details. For example, define the format you expect for the output and add examples of what you expect, which is a technique called few-shot learning. The other key thing here is that all of these is not done once for all. Prompt engineering is an iterative process of trial and errors. Handling refusal is also important. So when the model indicates the inability to perform a task, we can use that as an opportunity for tuning our prompt to guide the model towards a clearer understanding. In Azure Studio, the chat playground is the best place to start testing and iterating over your prompts, since you get an immediate feedback in an intuitive interface. Another feature which is helpful when working on prompt engineering is the prompt catalog, which provides a list of prompt templates for different use cases and tasks. So I want now to jump back to Azure Studio to see some of these prompt engineering techniques in action in the Azure Studio playground. But before that, I see a question from Andres Ricardo. How much does the effectiveness of prompt design and prompt engineering change from using it in one model to another? I'm not sure I've got your question right, Andres. So if you want to add more context, feel free to do so. Or if you want to unmute yourself and provide more context, feel free to do so. But what I can say is that, as I said before, of course, the model choice is very important. It's a first key step. So you need to, identify the model which is, which fits well your needs in terms of use case scenarios, in terms of training data, in terms of performance and cost. But the input you put into your model is also very important. So prompt engineering techniques really vary the kind of output you get from the model. So it's very important to learn this kind of prompt engineering techniques. So let's get into action and let's recall our scenario I've presented at the beginning of the session, which is creating a web design UI for an e-commerce website, and we want to have an AI assistant helping us to create this web design UI. Now, the first thing when you get into the chat playground is choosing the deployment, which means choosing the model you want to use as chat engine. In this case, I've chosen GPT-4o, which is one of the latest models within the OpenAI family, which is able to process multimodal prompts and generate an answer accordingly. And then here we have the system message we have defined in the slide before, which is a component of the prompt that it is used to provide the model with instructions. In this case, we are defining the task to complete, which is the assistant should pretend to be a web copywriter for the Contoso Outdoor Company, and its goal is to generate the website copy for the homepage. And you can see here that I also add some specification about the tone and style. For example, always show the word Contoso in capital letters. And then there's also some safety guardrails in here. I've added some safety guardrails in the system message. So now I hear some background noise. If you can make sure you're muted, if you're not speaking, it will be great. Thank you. Cool. So now that we have specified the model deployment and we have also configured our system message, the next thing is, of course, testing our prompt. And the first prompt I'm going to test is a very Easy one, suggest a tagline for the website landing page, just one sentence instruction. And as you can see, I get the answer very fast since it's an easy instruction. And even if I didn't mention about Contoso in my user query, since I have all this information in my system message, the model is able to use these additional context to create a more accurate answer. But let's do one step further. Let's make it better, because models like GPT-4o can generate more accurate and relevant answers if you break down the prompt into smaller parts. So next, I'm going to use a more complex prompt in which I'm breaking down the task of creating a website copy for the model. So I'm asking to do 3 things: write a short welcome message for the homepage, then writing a brief description of the business of my company, and then write a short description for each of the following product categories. And as you can see, I'm getting a more verbose kind of copy in here, which includes all the pieces I've added in my instruction. So I have the welcome, I have the business description, I have the product categories. So you see how just breaking down my request a little bit helped the model to achieve a better result. Now, another technique you can use to do that, to help the model break down the request, is the chain of thought prompting, where the large language model is responsible for breaking the task down into smaller steps. So the large language model uses its knowledge of the word and its ability to reason to generate a chain of thoughts that lead to the solution of the task. So let me do an example in here. Again, the request is similar. We want a website copy with the welcome message, the description of the business, and the description of the product categories offered. But this time we are asking the model to give reasoning before sharing the final answer. So we want to see how the model basically achieved the final answer. What are the steps used to achieve the final answer? And here's the answer. Let's see if it's loading. It's still loading. And you can see, when I use this kind of more advanced prompt engineering techniques, the model also needs more time to provide me with an answer. So bear with me while we have the final answer. Perfect. So you can see here that the model is answering with a reasoning as asked. So it is telling to craft a compelling and engaging homepage, we need to structure the content logically, and here's the step-by-step approach. So as you say, it is the model this time responsible to break down the request. And then it gives me the final answer, which is similar to what I've achieved beforehand. Great. Now, let's go ahead and make the model generate a list of product names to add to our website copy. And for this task, we are going to use a method which is called few-shot learning to provide examples that can better steer the model to the desired outcomes. So I have another prompt in here, which is this: create a list of 10 product names and include the type of item. So I have a set of examples in here in the format name of the product, category of the product. So let's see what the model get back. So the answer is in the same format I've provided in my examples. So name of the product and then category. And so we've got our 10 products names and categories we have asked for by using this few-shot prompting technique. Now, another thing I would like to showcase to you is multimodal prompting, because we have seen a lot of examples for text input, text output kind of scenarios, but prompt engineering is not just about text. So as mentioned earlier, GPT-4o is a multimodal model, which means it can process both text and images. So let's see how it works with the combination of an image and a textual prompt. We have changed a bit our system message. This time, our assistant should be a web designer for the Contoso Outdoor Company, but its goal is to generate the website code snippet for the homepage graphical user interface. And so we can do one thing. We can upload an image in here, which is a sketch note of I've created, I've drawn for my website layout. And then I can couple this with a textual prompt, which is generate the HTML and Bootstrap code to implement the UI of the e-commerce landing page based on the hand-drawn sketches in the image. And so if so this is the image I'm providing. As you can see, it's just a sketch note of a website layout with an example of the section of the website page with the product's catalog description. And so if we look at the result in a moment while it's loading. Nice drawing. No, it's not a nice drawing, but thank you. Bear with me. Of course, I'm also in a Teams call, so it's slower for this reason, because my connectivity bandwidth is shared with the call. Here we are. So what we get is what we asked for, basically an HTML file with for my website. And so I know it's hard to visualize these in here in the playground, but if we copy these and paste it in Visual Studio Code, for example, we can see the preview of the website. And what we are going to see is that we also have some placeholders for the images, because of course I didn't provide any images of the products, but I have all the placeholders in this template that I can then fill in with my own images of my products. But still, I have a skeleton for my web design HTML code, which is very useful. Cool. So let me come back to the deck once again, because we have some more to cover. And happy to hear that it will help with your development project, Dia. Cool. So by talking about inputs to the model, we can't avoid talking about data. Data is really the fuel for generative AI. But activating data has many challenges, complexity for one, especially as data sources are more multidimensional and not just structured. And while models are evolving quickly, data is also generating faster, making it hard to ensure you are surfacing the very latest information available. And the other knowledge gap these models have is about all the data protected by firewall they cannot access. So differentiation to us is about the grounding and customization which separates high-performing generative AI experiences from others. Now, by looking at the prompt components, we said we can provide the model access to private and or fresh data by adding the information into the prompt. And the thing is, the data we provide to the model should be relevant to the user query, so dynamic and limited in size, because larger the prompt, higher the latency and the pricing of the call. So here's where patterns like retrieval augmented generation described in this slide comes into play. So retrieval augmented generation, or RAG, is the architectural design enabling to store custom business data, retrieving relevant data to the user query in an optimized manner, and then use the result to inform the large language model prompt. So the way it works is the user inputs an initial prompt, which is used to search a data source and retrieve relevant grounding data. The grounding data is used to augment the prompt by adding additional contextualization and scoping text. And the augmented prompt is submitted to the large language model, which can then generate an appropriate response in natural language. Now, the data relationship plays a central role in applying retrieval augmented generation effectively, and this is why data and AI strategy must stay very close. Here are just a few of the best practices that developers are implementing to make the most of generative AI with RAG. First of all, chunking, so preparing data to ingest into the data pipeline by splitting your documents into more efficient and manageable pieces called chunks, by using a strategy that can optimize the search process, because related information should be in the same chunk. Then we have vectorization, which is another data preprocessing step that creates encoding to represent your data chunks into a numeric format. And then by using vectors, because the content is converted into numeric encoding, you get basically a common basis, and the search engine matches on vectors that are the most similar to the query, with no requirement for matching on exact terms, language, or even format. So you can look for images by using a text query. Then you have indexing, and to explain what a search index is, a search index basically describes how your content is organized to make it searchable. So you can imagine a library that contains many books, and you want to be able to search through the library and retrieve the relevant book easily and efficiently. And to make the library searchable, what you do is you create a catalog that contains any relevant data about books to make any book easy to find. So a library's catalog serves as the search index. So when vectorization is enabled, the user input encoded into a vector is used to query the index, enabling faster retrieval of relevant data. And finally, we have ranking, which is the last piece of the retrieval process. So once you get a list of relevant results from your search, you want to order the resulting chunks in a way to prioritize them based on deep meaning. Now, I know that this might look quite complex, maybe overwhelming, but Microsoft is focused on simplifying the process of connecting your AI solution to data and formatting it correctly. So to get the best-in-class search service in Azure, you should go with Azure AI Search, which provides the infrastructure and tools to create search solutions that extract data from various structured, semi-structured, and non-structured documents and index them, enabling optimized search over several Azure data sources, but also third-party data sources and on-premises files. It provides out-of-the-box features taking care of the end-to-end data pipeline we discussed before, from chunking up to semantic re-ranking. However, it's not the only option you have in the Azure ecosystem, because, for example, if you already have your data stored somewhere, like an Azure Cosmos DB or a SQL DB, you can keep your data where it is and leverage the built-in vector extensions to perform vector search without, provisioning further resources. Now, no matter which option you choose, in the Azure ecosystem, your data is protected by the most comprehensive enterprise compliance and security controls. So your data is your data. And when you build your AI solution on Azure, you build on trust. Since we don't use it to train our foundation models, we don't use, we don't do anything with it. So data is kept secure and remains in the same region you have selected, reflecting Azure's commitment to data security. Well, now we covered model discovery through, the model catalog, model benchmarks, and also differentiation. We covered techniques like prompt engineering and retrieval augmented generation. To put all these pieces together, you need an AI orchestrator tool to streamline the end-to-end development lifecycle. In the Azure AI ecosystem, you can rely on Prompty, which is a language agnostic prompt asset class and format to create prompts and engineering responses. It has three main components. First of all, the specification, which is a standard format that unifies the prompt and how it is executed into a single asset. The tooling through a Visual Studio Code extension, including things like syntax highlighting and variables validation, but also more complex stuff like code and evaluation generation. And finally, the runtime. Because you need the prompt basically includes an engine that understands and can execute the prompt format. So let's now build a simple application for our website designer scenario, because in the previous demo, we used GPT-4o to generate website copies and other assets without providing any specific context of our Contoso e-commerce website or in general our Contoso company. Now let's do one step further and let's provide our model access to the e-commerce products catalog in a way it can generate more relevant content for our website. So let's jump back to Azure Studio, where I have already added my data to this Azure AI project by uploading a CSV file containing the product list with the descriptions of the products. So I have basically uploaded a CSV file containing all this information, the name of the products, the price, the category, the brand, the description, and so on and so forth. And then what I've done is I created an index. So the object we say that basically serves as basically a book catalog in a library, and which describes how my data are stored in my data source and optimize the search process. So I created this index through Azure AI Search Service and to optimize search across my products list. Now, let's see how this data is used alongside my GPT-4o model instance in my solution by exploring my application source code in this GitHub repo that I will provide you. I will provide you the link to this repo at the end of the session. So you will be able also to replicate the demo on your hand if you would like. So I'm in a GitHub code spaces right now, which means I'm able to run this application in a Docker container, in a remote Docker container in the cloud. And all the app source code of my application is stored in this web designer application folder. Which includes this create website copy.prompty file that defines the model configuration and the prompt specification. So as you can see at the bottom of this file, you can see some metadata like the description, the authors, the model configuration, model parameters, and also a sample input. Which is, in the case of my application, is composed by a question and a context variable. And then I have the system message. So what a system message very similar to the instruction we have added into the playground in the system message field. We have in our application, we have them in here in this prompty file. And then as you can see, we have two variables for the context and the question that are retrieved at runtime and added in here to replace these placeholders. And then the other important file in my application is this Python script, which basically contains the application logic. And especially you should focus on this get response function, which is responsible for converting the user query into an embedding, so what we have called vector, using text embedding Ada OpenAI model. Then it uses the raw question plus the embedding to perform a hybrid search in the product catalog index and retrieve the context. And then it loads the prompty file, and it uses it to combine the system prompt with the user query, which is what we call questioning here, and the context retrieved by searching through my products catalog. And then it uses this final prompt to generate the final response using my GPT-4o model instance. And in my main function, you can see that I'm using as a question for this example, this one, create the website copy for the TENS catalog page. So what I expect by my application is that this question is embedded into a vector used to search across my products catalog list to retrieve information relevant to the TENS that my Contoso outdoor company sells, and then gives me an answer which is grounded on the information retrieved. And so I can test this application by just running this script in here. And the first thing it is printing out in the console is the context retrieved from my product catalog. So you can see here that this is looking into my products.csv file, and here it is printing out basically the document chunk relevant to the question, so relevant to the TENS products. And then it is also printing out at the console the result. But it's not very easy to, see the result into a console. So I want to showcase how we can leverage the prompty traces UI feature to inspect the result of my application, but also the intermediate step. So here we can see my input to the application, which was my question, create a website copy for the TENS catalog page. And I can see the final output, which is, the website copy I have requested. And as you can see, it is grounded on the products catalog. So it is referencing products really existing in the products catalog and relevant to my query, which was about TENS. So here there's references to existing TENS in the products catalog. And then, as I said, I can also inspect the intermediate steps, for example, the embedding stage, the retrieve documentation function, the preparation of the prompted template, the execution of the prompted template, and so on and so forth. So I can use these traces UI to really debug my application. And if there's any errors, I can understand where there's error and how I can fix those. Cool. Yeah, I think this was everything I wanted to showcase for this application. So I can go back to my deck. And again, I will share with you this repo so you can replicate this demo on your own at your own pace. But if you have any outstanding question about this application, feel free to ask in the chat. But now I would like to cover the last piece of this session. Because once you have built your website designer prototype, the next step is how can you tell that the flow is good enough to be operationalized and then released into a production environment? And the answer is in the evaluation process. However, there's a few factors to consider. First of all, we need a way to measure if and how the answers from my system are incorrect, irrelevant, or even harmful. We need to face new attack methods that are emerging that ingest into the prompt harmful content that can let the system behave unexpectedly, what we have called jailbreaks before. And we need to define new metrics with respect to classical machine learning scenarios because foundation models have no reliable source of truth. So we cannot easily compute the distance between, the predicted value and the actual value, as we did with, traditional machine learning application. Now, evaluation is an ongoing process of trial and errors, and the introduction of generative AI models led to a completely new way to evaluate an AI system. So the approach here is we take a test set, we run so a bunch of inputs to test. We run them through the system, which generates outputs, and then we evaluate those outputs against one or several predefined metrics, which will give us a performance score, so a level of quality of our application. Now, the evaluation can be manual, so we have human agents inspecting the outcomes of the test and evaluating how well the system responds for the given input. But it can also be AI assisted, which means we use another generative AI model to score the quality of the responses given by the AI system. Now, the first, the manual evaluation, is important to ensure an accurate validation, but the second one, the AI-assisted one, is very helpful to scale the testing process. So the two are complementary processes. And this process is not done against once for all, but should be redone every time we implement a change or improvement that we found necessary in the previous evaluation iteration. And there are several metrics to evaluate our solution from a generation quality point of view, from a safety point of view, such as we can inspect if there are any sexual harms, toxic language, or bias in the content. And we can also define custom metrics for our application. But for the sake of our session and our example here, we're going to focus on the generation quality performance. And the most common pre-built metrics you find in the Azure AI platform are 4. Groundedness, which measures how well the model's generated answers align with information retrieved from the data source. Relevance, which measures the extent to which the model's generated responses are pertinent and related to the given user question. Coherence, which evaluates how well the model can produce an output which basically resembles human-like language, and fluency, which evaluates the extent to which the generated text conforms to grammatical and syntactic rules and is appropriate, use an appropriate vocabulary. So I have a very last demo for the evaluation piece. And in this demo, we are going to evaluate the performance of the prototype we built in the previous demo. And Azure AI provides the ability to use AI-assisted evaluation tools to score the generation quality of our application. So it helps us to overcome the lack of ground truth for generative AI models by instructing a second model of our choice. We are going to use GPT-4 to evaluate the input-output pairs generated by our application against the predefined metrics we have just defined. So let's come back in Visual Studio Code, because for this demo, I'm going to use a Jupyter notebook, which is, again, hosted in the repo I'm going to provide you the link with. And in this notebook, which is called Generation Quality Eval, this notebook performs the evaluation of the application we built in the previous demo against a sample test dataset provided again in the repo. So the first thing we do here is we configure the Azure OpenAI model instance, the GPT-4 model instance we want to use for evaluation. Then we upload the test dataset, the test dataset that, as you can see, is a very simple dataset. We have just 3 questions. Then we import the class evaluators for the 4 metrics we want to use for evaluation. So relevance, groundedness, fluency, and coherence. So in Azure AI, there's some built-in evaluators that we can rely on. And then we define a unique name for the batch run of the target application we want to evaluate. And then what we do here is, this is the most, the core piece, because we are going to use the evaluate function of the PromptFlow SDK by specifying the batch run ID, the unique batch run ID we have defined before, the test dataset we want to use for the evaluation, the target function, the get response function we have seen before in the Python script, which basically called the GPT-4o model to get a grounded response. We define the evaluators we have imported before, and we also define, we also map the the evaluator inputs with the outputs of my target function, which is the answer and the context retrieved from the products catalog, which is used specifically for the groundiness score. And then the question is extracted, of course, from my test dataset. And then I've also added in here the specification of my Azure AI project, because I want to visualize the results of the evaluation in Azure AI Studio. So I have it printed in here, but I want to showcase them to you in Azure AI Studio just because it's a nicer kind of evaluation that we get. What we get here is, first of all, the ranking we use for evaluation for each metric goes from 0 to 5, where 5 is the maximum value we can get for each metric. And as you see in this dashboard, I have the aggregated average score across the whole data set per each metric. And then I also have the detailed results. So for each input-output pairs, I have the score assigned by my GPT-4 model to my input-output pairs. So I can inspect, where my model or my application in general is performing well and where it needs probably some improvements. Now, again, evaluation is an iterative process in which you use the results of an evaluation run to improve your application and then reevaluate it. And for the sake of this demo, we used a very simple data set, but in the real world scenarios, you should use a data set which is representative of the real data your application will be handling. And once you are satisfied with the performance of your application flow, you can move to the next step, which is migrating from a local environment to cloud. For example, by deploying the application as an online endpoint. So that was it for my final demo. So I would like to wrap up and then open the floor for questions, if any. And what we have seen today is we have seen as Azure AI is the platform that gives you everything you need to build generative AI experiences that scale. So we covered the Azure AI platform in general, Azure AI Studio specifically, and the features to be productive with AI. We have covered prompt engineering and how you can easily add your own data with techniques like retrieval augmented generation in Azure AI using Prompty. We have covered tools that have been created to help you fine-tune and evaluate your AI models and the responses that they produce. And as I have promised it, this is the QR code and the link to the repo, which hosts not only the demo code I have presented today, but also the tutorials to replicate on your own subscription, all the 4 demos I've showed to you today, together with the slides I've presented and some other train the trainer useful material. So feel free to use this material to present on your turn, to your community for any kind of upcoming session you have. You can rely on speaker notes, demo videos. Feel free to use this content as you'd like. Yeah, Christina, go ahead. I want to open up the floor. Oh, I've seen your hands raised. Maybe it was a mistake. But anyway, if you have any questions, feel free to either add them in the chat or just unmute yourself and ask. So I've seen your question about, is it possible to join this technology with the model designed in Figma? How would you like to join? So do you want to have the 2 models interact? What's exactly your goal in here? Can you elaborate a bit? If you are still here, not sure if Saul is still here. Yes.
I think he's still on the call.
Okay, I don't want to put him or her on the spot, but you know,
Okay.
I'm happy to answer your question, but I would need some more context about what's your goal in here.
I really don't know what he actually wanted to say, but then as for me, I'm a backend developer, right? Okay, he just asked. He said, if make a design in Figma that AI can make the code about this. Yeah. Okay.
Oh, okay. Yeah, I think he was referencing to the example of my sketch note.
Yeah.
Yeah. So I can't recall what's the output of Figma. I mean, if you get an image as output, then yes, you can give it as input to the GPT-4o model, and as I've done in the demo, ask the model to create the HTML file for you. So the important thing is that you have a JPEG, PNG, an image kind of format as input, and then you can do what I've done. It shouldn't be. I mean, it's more complex for the model. It's more complex to analyze a handwritten or hand-sketched layout rather than, of course, a design that you create. You digitally create. So from Hillary, I see, how can I start using the Azure AI platform for building my models? So if you want to build, if you want to use a pre-built large language model or small language model, and you want to augment it with your data, as we have done today, I would say start with Azure Studio and start with the model catalog in Azure Studio. While if you want to build your model from scratch, like in a traditional machine learning scenario with your own data, you should learn more about Azure Machine Learning Platform, because Azure Machine Learning is the platform designed for data scientists or whoever want to create their model from scratch. I hope I answered your question. Any other question? Curiosities, comments?
Yeah, I guess you answered that question clearly. I don't know if any other person has any question. Okay, Hillary has his hands raised.
A follow-up. Go ahead.
Yes. I still just have a question in that part of whether I'm following up on that of my question, because currently when I'm building a model, I have to use Core Laboratory and I have to export data from I have to import data from Cargo. Now, is it possible to develop a model inside, like when you're using the pre-trained model, is there already pre-trained transformer models available in the Azure platform?
Yeah. In Azure Studio, you can find almost 2,000 pre-built models. So if you want to rely on a pre-trained model, definitely go have a look to the model catalog. And there's a few models that you can also fine-tune. So there's a few models available for fine-tune, and all of them, of course, can be augmented with your data.
It is fine, but then another question is: does it cost for me to access the Azure AI platform?
The cost is related to the usage of the models. So when you deploy a model and you use it for inference, you are going to pay per each inference call to the model, according to the token you give in input to the model and the tokens you get in output. And if you go into the Microsoft documentation, you will find all the information about the cost and you can estimate the cost, for your use case according to the length, the average length of your input and output, and depending also on the model you want to use.
It is fine. Now, my concern just related now to the environments, maybe the work environments, and maybe in our applications. Like now we are undergoing the boot camp. Now, how now they might want to test whether you've actually been using Azure AI platforms. Now, like the certification for Azure. Azure, we say Azure for data science. Are they costly, or are there free courses that we can take to enhance our skills on this?
So to be honest, I don't know the cost related to the certificates. There might be, I know there might be some, I know if you are a student, but if you are a student, there might be some benefits specifically for students. Yeah, maybe if you can, if you want, I can come back to you about Microsoft certification. If you want to email me, let me put my email in here in the chat. So if you need, we can follow up. I don't have an answer for you right now.
It is fine. Thank you.
And I see Andres Ricardo question, is there a cost by implementing some of these Azure solution in a university or private project? Of course, you always, all the things you do in Azure cost Azure credits. Now, I don't know how many of you are student ambassadors and how many of you are students. If you are student ambassadors, you have some benefits, some credits you might have some credits in a specific subscription, which is called Visual Studio subscription. If you are a student, you might benefit from an Azure for Students subscription. Yeah, I would encourage you to double check the benefits you have as a student, because there's benefits for free Azure subscription with a cap of Azure credits. As a student, I think you get something like $150 or something. So you can you can do some experimentation for free, basically. But everything you do in Azure, it costs Azure credits. But there are some benefits for students in terms of free subscription with a cap of Azure credits.
Okay.
Yeah.
Oh, I don't know if there's any more questions coming in from anyone. So I would just say thank you so much, because I mean, this section was really, really enlightening. I'm going to have to rewatch this section because I'm definitely going to practice everything.
Awesome.
I really loved what you did with the prompt engineering and prompting. Yeah. And I'm definitely going to practice on my own. Yeah.
Awesome.
So,
thanks, Olivia, for having me.
Yeah, thanks for accepting this. I don't know if anyone has any other questions, so we could call it a day. Yeah, the section was recorded, so I will definitely drop the recording. And yeah, Carlotta, I don't know if you have, if your slides is also linked to this link you shared with us.
Yeah, everything, you can find everything in the repo. All the material I've shared today, it's in the repo, including speaker notes.
Oh, Fantastic. So everything is on the repo, guys. So if you need any resources concerning her talk today or her section today, it's on this QR code. You could scan it. I already shared a picture of it on the WhatsApp group chat, so you can have access to that. And I would also be sharing the recording. But before we go, we usually do something quickly. We take group pictures. Yeah.
Oh, yes, please. I would love to do so.
Yeah. So I don't know if we are all camera ready or something. Yeah, you can just like put on your camera and I'll have everybody on. Yeah. Okay. Sorry, Carlota, can you stop sharing so we can have everyone on
yeah,
the
sorry.
big screen?
Yeah, of course.
Okay, I can see just a few persons. Oh, hello, dear.
Hello.
Let's
Hi.
take a
Hi.
picture.
Yeah, so I don't know if we are ready. I'm about to put this in together mode and have us together.
No worries for the background. I don't think in the group photo I think the background is cut in the group picture, so no worries about the background.
Okay, so we only just have about 8 persons or 7. It's fine. I'll just take a picture. Are we set? Okay, I'm taking another one. Okay, we have more people joining and let me just take them down. Okay, I think that's it.
Perfect.
Yeah.
Thanks, Olivia.
Thanks for joining in.
Thanks everyone for joining and for your questions.
Bye.
Bye bye.
Thank you. Bye bye.